and thank you for joining us today. For those who don't know me, my name is Eric Wright, and I'm the branch manager at Stan Weaver's Jacksonville office. I will be hosting this webinar today. Stan Weaver and Company is a leading manufacturer's rep in the HVAC industry, now with 5 offices serving most of the state of Florida. We currently have offices in Jacksonville, Orlando, Tampa, Miami, and West Palm Beach. Stan Weaver and Company has an unwavering commitment to excellence, and we position ourselves with only premier HVAC manufacturing companies. After this meeting, in your spare time, please check out our new website at stanweaver.com. This is now a great searchable line card under the manufacturer tab on our website. When you're in search of a product for your project, always start with stanweaver.com. Moving on, this is our third of a 10-piece webinar series Stan Weaver will be hosting throughout this year. We appreciate everybody taking their time out of your busy mornings to learn and educate yourself on a great industry manufacturer. A few housekeeping notes before we begin. Just to let everybody know, this meeting is recorded. Again, this is the third of 10 webinar series that we'll be hosting this year. If you made it to our previous webinars and now this event, you're another step closer to getting a chance to win an iPad. These presentations are no more than 30 minutes in length, and then there'll be a Q&A section at the end of the presentation. We have muted all attendees for the length of the meeting. We will be utilizing the Q&A function within the Zoom program located on your screen. If you have any questions throughout the presentation, please submit them in the Q&A section, and we will get to all those at the end of the presentation. Lastly, there is a survey at the end of the event. Please take time to complete and submit this survey for us. We review all submissions, and we will use the comments to better this series for us and all attendees moving forward. Now, with no further ado, let me present our speaker and topic for today. Mr. Jason Geegan, hailing from the great state of Texas, is the Vice President of Commercial Sales for RM Manifold Group. RM Manifold Group is the parent company for 3 different brands, inclusive of LFSystems, which we will be discussing today. Mr. Geegan has over 28 years of HVAC experience, starting in a warehouse position and growing through various sales and technical positions. A brief sidetrack into radio gives him an appreciation for presenting and discussing a variety of topics. He was also instrumental in the development and the research of today's presentation. Jason, the floor is yours.
Thank you, sir. And yes, I'll kind of echo Eric's statements. Appreciate your time this morning. We're going to jump right into it and talk about today's topic. We're going to get into multi-story buildings. A little bit about who we are and what we do. So our Manifold Group is a draft control manufacturer out of Fort Worth, Texas. As Eric mentioned, we have multiple brands that we go to market with. First, US Draft Co. focuses in the boiler room, doing draft controls for boilers, water heaters, pool heaters, any fuel-fired appliances. KW USA is a specialty product for residential and light commercial fireplaces, pizza ovens, and some specialty items that need draft assistance. The topic today, LFSystems, focuses in the commercial laundry space, as well as multi-story buildings and stairwell pressurization, which we're going to kind of cover throughout today's presentation. We're going to start with the high-rise exhaust of things, get into dryers, types of dryers that you get into, multi-story exhaust options, LFSystems solutions, stairwell pressurization, and our active compensated stairwell pressurization controls. So when it comes to high-rise exhaust, we're going to focus on 3 main areas: bathroom exhaust, laundry exhaust, kitchen exhaust. And we could talk about all 3 of those. Obviously, we're a little bit limited on time. And so we chose to focus on what I consider the most difficult of the 3, and that is the laundry exhaust. Everything we're going to talk about in laundry can apply to both bathroom and kitchens. But bathroom and kitchen have a little less stringent rules to them. So we're going to go with the toughest one and kind of work our way back from there. So there's 2 different types of dryers when it comes to code. Type 1 is your domestic for your residential single family living. Type 2 are more public for laundromats, fitness centers, or if you have a laundry room in your facility. We're going to kind of steer clear of those today. Maximum dryer length is determined by both code and the manufacturer. So IMC says 35 equivalent feet, every elbow equaling 5 feet. UMC says 14 feet plus 2 elbows. So it's basically about the same, that 25 to 35 foot range. The exception to that is if your dryer manufacturer allows you to go further. Um, but in single family apartments or condos, that can be difficult because that dryer can then be changed out in the future, and that dryer may not, the dryer purchase may not meet the requirements that you've designed for. One thing about dryers is they actually, when they're operating properly, they actually prefer an outlet pressure slightly positive. So on a type 1 dryer, you're looking at zero point 0.1 to zero point 0.9 inches of operating pressure. Keep that number in mind, that 0.9. We're going to come back to that here in just a second. The thing with dryers is it kind of emulates a modulating boiler in the sense, which is kind of more my background. This is how I can understand it, is a rated dryer CFM is based on an unloaded dryer with no ductwork. So that's assuming zero pressure drop through the dryer. It's going to run 180 to 220 CFM. But as you load clothes in, and as your dryer length, your vent length gets a little bit longer, that CFM goes down. So typically, a residential dryer is going to run between 100 and 150 CFM, depending on the load conditions, depending on the length of pipe. And that changes throughout the cycle. As clothes dry, there's less pressure drop. And so therefore there's more CFM blown through. So there's 3 ways to vent a dryer in a multi-story building. This is the first way. I don't recommend it, but it can be done. Obviously, there's a lot of bends and curves to this and a bunch of height involved. I've never seen a dryer be vented through a basement like this, but this was a published drawing in someone's book, so we thought it was somewhat comical. The more likely and more common option that we see is compartmentalized exhausts, where you'll have your termination for your dryer and your kitchen and baths going out the side wall of a building. And while this is an effective way of doing it, or it can be effective, it's obviously not the most attractive way to do it. So the developer and the architect, and maybe even the owner, just, it's not a great appearance to it, but it is a cost-effective way of doing it. The problem is, if you're dealing with a 15-story building, study was done at Cornell that says a 7-mile-an-hour wind can create 0.92 inches of back pressure on that exhaust. You remember back a few slides ago, the maximum pressure a dryer wants to operate at is 0.9 inches. So even if the dryer was up against the exterior wall and you had no pipe to speak of, you'd be already against its limits. And so the other concern, or the other issue with this, is typically your utilities are toward the center of the building. Therefore, your kitchens and your bathrooms are again toward the center of the building. Also, for aesthetic purposes, you want your living space and your bedrooms to be facing the exterior walls for the views and all of that. Well, the problem with that is the length of duct to get through that condo or that apartment. Easily can exceed that 35 feet once you get a couple of elbows in there. So what we recommend is what we call the shaft exhaust, or multi-story shaft systems. And there's a whole bunch of things that code talks about when it comes to your common exhaust shaft. It has to be fire rated. Can't have dampers in your ductwork on dryer exhaust. Can't have an offset on your shaft. The exception to that is once you get to the top of your building, you can go horizontal. At that point, it's no longer considered a shaft. Again, we can dig deeper into the code specifics. Have to have the fan running continuously. People ask, well, why do you need a continuous running fan? In an emergency, you're not going to be doing laundry. That's actually part of your smoke control system. So you have to make sure that that stays running in the event of a fire. Makeup air, obviously you have to make up all the air that you exhaust. Clean out at the base. Screens shall not be allowed. That's a big one where a lot of times people will specify a general exhaust fan and it'll come with a bird screen or a finger guard. And once this is pointed out, they remove the screen. Unfortunately, at that point, you're now removing the UL listing of that fan. So obviously you want to make sure you specify a product that's specifically designed for it. So then once you get into shaft exhaust, you have to determine, okay, we're going to do a constant volume system. We're going to do a constant pressure or a variable volume system. Constant volume, you turn the fan on and it runs until the motor dies, the belt dies, or the building is decommissioned, right? And while that works great on Saturday morning when everyone's doing laundry, on Tuesday night, 3 in the morning or middle of the night, no one's doing laundry. You're just pulling 1600 CFM out of that system, out of that building every single minute of every single day. So a variable volume system allows you to turn that fan down. And typically it will run at low speed 80 to 85% of the time, only during peak hours where you start to ramp that fan up close to its full capacity. So what you would do is you'd have a pressure sensor here at the base. And again, as required, that fan's going to modulate to maintain a slight negative within that shaft. Again, code says you have to have continuously running. It does not say you have to have constant flow. It's just a quick PID of what we consider the high-rise exhaust system. So we have our control unit, which is the brains of the operation, running to a fan, either directly with an EC motor or through a VFD. We're going to modulate that again based on pressure. We do have the required outputs for alarms. We also have an optional BMS output if you wanted to tie that into a building management system so you can see what's going on. Our DEF is a 90-degree fan specifically designed for laundry exhaust in two ways. One, it does have an access panel to get in and clean out any lint buildup that may occur. Although in most multi-story systems, that lint's going to fall to the base, which is again why you need that clean out. Variable speed motors, again, EC motors up to 1 horse, about 2700 CFM. Above that, we do get into a 3-phase induction motor. Those are all standard off-the-shelf motors, easily available at any local motor shop. It does have the UL listings required, is made of an aluminum housing, or excuse me, it's actually a galvanized housing, that's a typo, and an aluminum impeller, which is, again, spark resistant according to AMC. The L150, this is our kind of the brains of the operation. It's a true bidirectional control. I'll talk about what that means here in just a second. But we're able to maintain, again, the pressure in that duct so that we keep that shaft in a constant slight negative. High and low pressure safeties, which the high pressure safety is the thing you lose if you cannot do a true bidirectional. What's a true bidirectional? Well, most controls are a negative only pressure control. So they stop at 0. And when you do that, as you start to build pressure, the controller doesn't know any better. So it thinks it's at 0. So it's a slightly offset point. It'll slowly ramp a fan up. With us, we see a spike in pressure. Again, that Saturday morning laundry run or Tuesday night, 6 p.m., everyone's making dinner. Everyone's turning their hoods on. There's a big spike in pressure. We want to see that and change that very quickly. We were able to react to that, typically 50 to 60% faster. And the example I always use is if you were to put a temperature gauge on a water pipe and your target was 100 degrees, you would not put a 105-degree temperature gauge on it. You'd have no range on that, right? You want to make sure that you have space on either side of your target. Same thing here. We want to have space on either side of that set point so that if pressure builds, we can see it. If there's a huge drop in pressure, we can see that as well. So we're, again, able to react to that very quickly. Our multi-shaft controller, this is a great application for bathroom exhaust where you have very low CFM. And like I said, you can't do a offset in the shaft, but once you get to the roof, you can manifold multiple shafts together and put it into a single fan. This can save a little bit of cost on the fans as well as, but while still maintaining that slight negative. What we'll do is put a sensor in each shaft. This controller determines the speed of the fan based on the highest, lowest, or average of those 3. And then we'll, again, just modulate to maintain that slight negative. Does come with a 7-inch touchscreen, and all of the other features from our L series controller are also available in the L330. One thing I mentioned on shaft requirements is you're not allowed to have dampers in a laundry exhaust. Anything that can catch lint is considered a fire hazard. And so for your dryer exhaust, you need to use what's called the subduct method. And there's a whole list of what is required to be considered a subduct. Keep in mind, this is specifically designed for dryer exhaust, but you can also use it for kitchen and bath. This is showing a profile of a duct system. So this is just a simple 4-inch duct piped into a shaft and turned up, and it would work, but we offer what we call a low profile subduct riser around a rectangle transition so that it lowers that that profile of the subduct while also maintaining that 22-inch requirement. Again, to show more of a cutaway of it, simple, available in 4, 6, and 8-inch, and again maintains that 22-inch requirement by code. So when it comes to building a field fabricated shaft, there's several steps and several people involved. Step one, they got to build the ductwork, and then that ductwork has to be inspected. And then once the ductwork is inspected, hopefully they installed the subducts correctly, they pass inspection. Then they have to do a double layer of sheetrock with an air gap, and then 2 more layers of sheetrock, and that then creates your field fabricated fire rated shaft. That also has to then be inspected. A lot of people involved in that, a lot of material, a lot of time, a lot of labor. And so a few years back, we introduced what we call our prefabricated shaft system. This is a duct and shaft all in one. It's a 3-inch fiber insulated wrap around the ductwork, and then a finish sheet metal on the exterior. Also has the integral subducts available. So now, instead of having to build the ductwork, have it inspected, build the shaft, have it inspected, multiple people, multiple trades. This is all one piece. A couple of apprentices with a screw gun and a caulk gun can just stack it up like Lincoln logs. Meets all of the requirements for UL as listed to ISO 6944. If you're familiar with prefabricated grease duct or prefabricated boiler duct chimney, this is based on similar principles, but again, it does have that integral subduct, which makes it very, very helpful for multi-story exhaust systems. Also saves a little bit of footprint. So a 24 square shaft, you'd require 6 inches on each side, which means you're now gaining a whole foot. Whereas with the PSS, we're only gaining 3 inches on each side. We've shrunk it down by 6 inches. And again, a cutaway, single inspection, single trade. We typically save about 30 to 35%, mostly because of labor. There's a huge drop in labor. Again, you're not needing a master duct sheet metal fabricator. You're not needing a whole carpentry crew. A couple of guys with a screw gun and a caulk gun can stack this up fairly quickly. Let's talk about stairwell and elevators. And this all kind of does tie together. Again, your shaft system is part of your smoke control system. And so what moves smoke throughout a building is your stack effect. That's the biggest cause of smoke movement. So all of these shafts that we just talked about, that's going to draw smoke in. And if you don't have that continuously running fan, it could potentially make its way through into other units. But we have to take that into account when considering smoke control. The other thing that moves smoke is the pressure caused by the combustion of the fire. So when something catches on fire, smoke gets pushed away from the flame. And then if you have a sprinkler system, that water sprays on the fire, flashes to steam. Steam creates a pressure wave as well. So it's pushing the smoke away. This is a typical pressure profile of a building. The light blue line that you see directly, a straight diagonal, would be if there was no leakage between floors. Everything was perfectly tight. There was no shafts. Everything just was perfectly sealed. That's not real life. We have shafts, and then also there's always going to be a little bit of leakage in your building, which actually creates it a little bit more like this squiggly blue line. And the problem with this is a wintertime condition. And in the summertime, the building flips. Now, obviously in the state of Florida, you guys don't have as much of a winter as, say, up in the Northeast or in the Midwest. I'm here in Texas. We don't as well. But there are still days that it gets cool. And so you do have to change, account for that, 35-degree morning and then that 95-degree summer day, because that does change the operation of your building. So we have to take that into account when dealing with smoke control. And there's several ways to do stairwell pressurization or stairwell containment. We don't have time to talk about all of them. We do have a complete webinar just focused on stairwell pressurization. We'd love to provide for you in your office. Just get in touch with your local Stan Weaver rep. But we're going to focus on the active system that involves fans and dampers, controls, and then we're also going to focus on a multi-point injection. Again, if there's questions on what these all mean, definitely give us a call for the webinar. So when you're considering this, you have to remember fire creates its own pressure. The fire floor typically needs 40 to 50% increase in air to make sure that the smoke is contained. Conditioning your smoke pressures, your stairwell pressurization fan actually makes systems worse because of that natural stack effect. Open doors below the fire floor in the winter don't require as much as they do above the fire floor. Again, in the summertime, that does flip. So for the state of Florida, that's actually more of a concern on the lower floors. Undersizing your fan may worsen smoke entry than if there was no fan at all. And that one always threw me. And what they found is if you design a system where the whole point of pressurizing your stairwell is that you're lowering the neutral pressure point of the building. And if you design it to push it to the bottom, which is what you want, because you want all of that fresh air pushing into the corridor, not being drawn into the stairwell. If you have an undersized fan, that neutral pressure point starts pulling up and it creates a vacuum effect on those lower floors. Starts drawing smoke in, and then it starts to rise because of natural lift. And then that pressurization takes over and blows the smoke into those upper chambers, upper corridors, excuse me. So we definitely want to oversize the fan slightly and then control it back. How do we control it? Well, according to IBC, any system equipped with a control unit shall comply with UL 864 and listed as control system. And we could, again, get into 864 and what all of that entails, but a quick cheat sheet is this little figure right here, 50.1. It says basically anything inside this dotted box is required to be listed to UL 864. Anything outside of it is not. So it's pretty simple. Your FSCS, your controllers, your PLC, your point logic controller is optional. Not sure if you can see that, but it does say optional for UL. Outside is your motor control, that's your VFD, and then any accessories for your drive. And what a lot of people see is they take that as, well, I can use a VFD with a pressure sensor and it doesn't have to be listed. Fortunately, that's not the case. Because you're now making decisions with your VFD, that becomes a point logic controller by definition. So I always say if it's making decisions, if it's doing something smart, it's inside this box. It's got to be listed and tested. If it's dumb, it's just doing what it's told, which a standard VFD does that, right? If another controller is making that decision, sending that signal to the drive, and the drive is just moving a fan, it's just a dumb device doing what it's told. And so in that scenario, it does not need to be listed. And I've had arguments with drive manufacturers, some that we actually sell over this topic. And so just know that you have to have, if you're going to do a pressure-based control system, that control system has to be listed to UL 864. And the main reason, or the main hang-up, if you will, for most and why they are not listed to the standard is what's called circuit integrity. So a very, very brief description of how my controls work. Every other controller that I sell has a simple start-stop command, okay? If you want me to turn on, then you close a contact. If you want me to turn off, you open the contact. It's a light switch. It's very simple, right? With our stairwell controller, we have to have an on switch and an off switch, a run and a standby. And if there's ever a conflict between those two, we have to go into alarm and go into run. And reason being is we assume there's something wrong. Something has happened to where we need to turn the fan on and see what's going on. So rarely do we have two closed contacts. That's just not something that we see. But if there's a short or there's something going on where the run contact can't close because a wire has been cut or shorted out, but the standby opens, there's a conflict, controller is going to go into run and again send out that alarm. And that's where the circuit integrity is a big integral part of your UL 864 listing. So my sensors, all my pressure sensors now have to be 3-switch instead of 2-switch. And so that's why a few years back, right in the middle of a pandemic, nonetheless, we introduced the active compensated stairwell pressurization system. It's a big bunch of words, so we just call it the ACSP. The system is recommended with a fan up on the roof. Control, again, the brains of the operation, taking all of the information as required by code in and out of the fire alarm system. Optional Modbus is available. 3 sensors, one at the top, one in the middle, one at the bottom. We're going to take the highest, lowest, or average of those 3 sensors and modulate that fan to create a slight positive. That's it. It's very simple. Works very similar to all of our other controls. Just in this case, we're blowing air in rather than taking air out. More of a close-up of the controller. So it's fire engine red. So it's very obvious that this is a smoke control or life safety device. It is the first PLC dedicated to stairwell pressurization listed to UL 864. Does have the dedicated IO required for the FSCS, and again, up to 3 transducers. I always like to show a picture of stuff because I'm a sales guy. This is kind of how it gets through to me. And that system probably would work in 85% of the systems in the state of Florida or in the Southeast. You start doing business up into the mid-Atlantic or in the Northeast, Midwest, there is a point where the differential between the top and bottom of your building is too great to maintain the minimum 10th inch required by code without exceeding the maximum 0.35 required by code. So if that quarter-inch difference between the top and bottom of your building exists, we have what we call our advanced system. And it basically involves the same master control, but it also has these little sub-controllers. And instead of describing it all, I'll just show you again those pictures. This controller is now going to maintain pressure in this duct and modulate to maintain a slight positive here. And then each injection point gets its own damper, its own controller with its own set of transducers. And so now, as doors open and close, only the injection point where that door is going to open as needed. So we're just going to open that damper to maintain that 1/10 of an inch. So it really becomes, we'll call it a primary secondary system, right? A macro micro control where we can get close in the ductwork, we can get close with the fan, we can trim it out with these dampers. Sense? First question I always get, and I'm sure one of them's in the Q&A right now. Can you do this for elevator hoistways? Absolutely. Similar box, not exactly the same, but it internally it's got a few algorithmic changes. But if I put 2 of them side by side, you'd never know the difference. Again, controller. These controllers typically go in the command center next to your fire alarm panel. 3 sensors, highest, lowest, or average. Like I said, the main difference is the algorithm. There's some piston effect that happens in an elevator you got to account for. So we took that into account. Some common cautions. This came from either ASHRAE or some codes. Single point injections are not recommended over 100 feet. This was an ASHRAE research project that concluded anything over 100 feet. By code, you have to do an analysis. We'd recommend just doing a multi-story or multi-point injection system. Non-compensated systems, turning a fan on and hoping for the best can work in very, very, that 76 to 78 foot building. You're just over the height requirements. You might be able to get away with it, but you start pushing beyond that. Compensation is the way to go. Don't use a non-listed system. According to IBC 2018 and beyond, mechanical systems are required to be listed to UL 864. This is something that a lot of people overjump or overlook. And no, a VFD is not listed to UL 864. We have a nice little infographic. We can kind of map you through that if need be. How do you specify it? Well, we can help you with a stack effect calculator. You get us the height of the building, temperature, design temperatures for, summer and winter, and then we can show you that. We like to tie it to the notes of the fan schedule. Sidebar, Green Heck is the only fan we're approved for in the state of Florida. I'm just kidding. We are listed with any smoke control system. We can provide diagrams. We can provide written specs. And it looks like I am right up against the clock. So Eric's giving me the 2-minute warning here. So I'm going to go ahead and wrap it up with that. If you have any questions, if you have any more details you'd like to know about either multi-story or stairwell pressurization, elevator pressurization, or any of the other products that we offer, rmanifold.com, take you to the website and it'll select the brand that you're interested in. We're also involved in LinkedIn. YouTube has a lot of our previous webinars online. So yeah, we'd love for you to join us. Eric, I know that there's a few Q&As it looks like, so if we want to jump on those.
Yes, sir. Thank you, Jason. Great presentation, and thank you again for all the attendees that attended. If you have any questions, please again use the Q&A function here at the bottom of the Zoom program. To start off, Jason, the first question is there a particular reason why the prefab PSS is round versus rectangular?
Yes, that was what was available to us from a fabrication standpoint and a listing standpoint. I can neither confirm nor deny that we might be working on another option in the near future. So maybe stay tuned for later this year here an announcement about that. But currently, it is only available in round.
Very nice, very nice. And then another question was, is this PowerPoint available? Can you get that to us, Stan Weaver, to share to any contractors?
Absolutely, absolutely. Yeah, we can.
Yep.
Yep. Yeah, we can get your slide deck, no problem.
Awesome, awesome. And any other questions, please put them in, guys. Just a few comments I had. We've been working with RM Manifold for many, many years. I'll tell you the controllers that Jason mentioned there towards the end. I know he flew through those, but those are a common phone call we get all the time, and it's a great solution, a factory package solution, if you will, as well, other than having to get a controls guy to piece all those together. So definitely keep those in mind for all the engineers on the call here. And then also, I just wanted to touch base on those subducts as well that he hit on early. We see those in multi-story apartments. We also see them in hotels a lot of the times. They're a great option instead of putting life safety dampers and stuff in the shaft walls. So again, Jason and I was a stickler with sticking him to 30 minutes, and I appreciate that. But we could go on for hours about this stuff. But if anybody wants any more details, please reach out to your local Stan Weaver representative, and we'll get Jason in town or on a specific virtual meeting to answer all those questions. One other question just popped in here, Jason. Do the roof mounted exhaust fans have integral VFDs, or would that be required to be mounted into space by a third party?
Sure. So the smaller fans with the EC motors, those don't require a external VFD at all. That's kind of integral to the motor. A three-phase motor does require a drive, and that is external. We have seen in that scenario where they'll put them in a NEMA 4X enclosure outside, but in most cases, there's a penthouse electrical room or some kind of a switch room that those can be mounted in. And they're micro drives. They're size of a shoebox, if that.
Very nice.
But just one point to that, with the subducts, and again, I'm not here to take away, fire smoke dampers, but it's a huge cost savings. Obviously, no inspections, no panels, no inspection panels, no power, no maintenance. It really can become a great option for, doing shaft exhaust again for bathrooms, kitchens. Even if you're doing a constant speed shaft system, the subduct method is a huge time and cost savings.
One last call for questions. Well, with that, I guess we'll close it up here. Thanks again, Jason. Thanks again, all the attendees. Again, reach out to me. My email is in the chat if you would like today's presentation or would like to set up a further meeting with RM Manifold, LFSystems, or reach out to your local Stan Weaver representative, and we can get you lined up. So thanks again, and everybody have a great day.